Let's move on to our next tech talk. So, isn't the idea of building distributed cloud platforms and products for like 1 billion users interesting and intriguing? Like, how do you do all that for different kinds of companies, ensuring stability and reliability? So, let us all know about how to build distributed cloud platforms at scale and what challenges are faced to build these complex systems by our next speaker, Mayank Kapoor. Mayank has been building cloud native platforms for over a decade now at companies like Apple, Jio, Car Dekho. His products and platforms have been used by hundreds of millions of users. He was a VP of engineering at Jio when Jio grew from 0 to 400 million subscribers. He is currently VP Product and Technology at cardekho.com, and he has BTech from IIT Delhi and has an MBA from MIT Sloan. Over to you, Mayank.
Thank you, Tarushi. Very happy to hear all the talks today, from cloud security, service catalogs, performance engineering. Very interesting talks, by the way. This one might be a little off the vein, and I'm the one standing between lunchtime as well. So I'll try keep this interesting. So let me see if I can share my screen. And I think I need to share my audio as well. Hope you guys can see.
Yes.
Awesome. So just taking you through some lessons learned, building cloud platforms which have been used for quite a few users, and just sharing some stories along the way. So a bit about me, graduate from IIT Delhi, have an MBA from MIT, built robots at Apple, and I also managed to run some assembly lines in China, build cloud products for Jio, and saw Jio grow from 0 to 400 million, build the used car platform at cardekho.com, and currently CPTO at Cardekho Group, building the state-of-the-art auto tech platform for India. I can be found on LinkedIn. You can reach out on Twitter as well. So the agenda today is we'll talk about Apple and robots. We'll talk about the process of building reliable systems. We'll talk about what it means to build the internet for 1 billion people at Jio. We'll talk about matching cloud strategy to the company strategy. We'll talk about building the personal mobility platform for 1 billion at Cardekho, and overall building efficient and reliable cloud infra. And we'll summarize everything at the end with lessons learned. So we'll talk about Apple and robots. So at Apple, I was building engineering systems that were a mix of hardware and software. I was essentially building robots for Apple, and these robots were designed in Cupertino, California, where I was working, but they were installed in factories in China. Liam is our most famous robot. You may have seen it, you may not have seen this video, but let's start. This will give you a sense of what a robot was at Apple and how it was used. So hopefully you'll be able to hear the audio as well.
The iPhone is the result of years of innovation. But true innovation means considering what happens to a product at every stage of its life cycle. Meet Liam. When it's time, Liam deconstructs your iPhone. Parts are detected and removed and separated. So the materials inside those parts can be repurposed to rescue cobalt and lithium from the battery, separate the gold and copper in the camera, extract silver and platinum from the main logic board, so the materials in your iPhone can live on. Because in a world with limited resources, some things can't be replaced.
So Apple is really good in marketing videos, as you've seen. Very well made, this video. the best thing that this particular robot did was it removed people from touching, unsafe materials like nickel, cobalt in the assembly lines, because previously it was all being done by hand, and still quite a few operations at Apple factories are being done by hand. So these robots, first of all, made it safe, this particular operation, and many assembly line workers were saved from disassembling these iPhones and iPads. So very useful application, very well received. The challenge with building robots is that these robots have to be deployed in these assembly lines in China, and the uptime requirements and the reliability requirements for these robots are very, very high. We are talking like 99.95% uptimes. If this robot stops, the entire assembly line and the production stops, right? It's really big deal for Apple to keep the assembly lines running. And that's why it was really challenging. But at the end, we did manage to automate quite a few stations per assembly line. I think if I remember, around 15 stations we managed to automate per line, and there were like hundreds of assembly lines at Apple factories. So most of them were testing stations with tested iPhones and iPads, and quite a few were manual assembly line operations as well. And the best thing I took with me from this experience is the process of building reliable systems that never fail. And I'd like you to walk you through my thinking. A lot of my thinking on software development is derived from this experience. So let me walk you through my concept of the software assembly line. So I think of software as a process, and you could think that you're trying to run an assembly line building software products, which goes from the initial phase of scoping your software, designing your software, which moves into development, then goes to testing, goes on to your release stage where it's regression tested, and then you go live with the software. But at each and every stage, if you think of it as a process, you can think of monitoring the process KPIs at each stage. So during scoping, you would assume that your product managers are creating user stories for your software. And you can monitor whether the user stories are adhering to your story template as a process KPI. Because what I found is if these stories and if process is followed over time, it yields to great quality software. So that is one process KPI that you can measure, whether it adheres to the story template that you've agreed in a team. Does it have acceptance criteria? Does it have product KPIs? And you can match how many stories do not adhere to it. And then you can understand, try and ask why. Why was this not done? Then it goes to development, where developers build the software. And in that process, they're also writing unit tests, and they're trying to, you can monitor the number of unit tests being written, the number of the code coverage developers have for their code. Are they giving a demo to PMs and QA and stakeholders during the process? Because that will yield to good quality software. It comes into testing, where you can monitor process KPIs like how many test cases were created for testing the story. And then very important is how many bugs were found per story. And then you can, over time, minimize the number of bugs happening per story if you analyze why they were happening in the first place. We go into regression, where we are trying to do regression testing of our software before release. And you can monitor how many regression tests were done and how many regression issues were found. And when you actually go live, you can monitor the process KPI of production issues. How many production issues were found? And did the product KPIs actually improve that how they were defined in the beginning and when they were actually released? And you close that feedback loop. So I use this mental model of a software assembly line to build reliable software and systems. And hopefully this will help you as well when you think of building software and product. And one framework that has really helped me improve the software I'm building, the systems I'm building, is the concept of asking the 5 whys for any issue, which leads to your root cause analysis. So 5 whys is essentially a framework where you keep asking 5 questions, 5 whys, to arrive at the root cause of the problem. And let's take you to an example. This is a very common example, by the way. So in one of the systems, the payment was not processed. You ask the first question, first why was the payment not processed? Then you get the answer from the team, hey, because the payment feature wasn't working. Then you ask your second why wasn't the payment feature working? You get the answer, the API to process the payments threw an error. And then you ask your third why did the API to process payments throw an error? The answer you get back is the third party system being used to send payment was responding very slowly. And this is quite common, by the way. Any dependent systems have a variability to the response, and some systems will respond quite slowly sometimes. And then you ask your fourth why did a slow response cause an issue? Then this leads to a bit of thought, and the team comes back with saying our integration is tightly coupled and it waits for a response from this third party system. If it doesn't get a response in time, the flow breaks and the payment is not processed. So then you ask, okay, the final why are the systems tightly coupled? Which again, the team thinks a bit. And then the answer, if they're thinking really nicely, is that there's actually no good reason to tightly couple systems together. We should have made the design asynchronous and loosely coupled the two systems. So there is an amount of failure handling in place as well. So with this 5 whys framework and the root cause analysis, you can arrive at the root cause of the issue, and then you can implement a root cause fix so that this issue never happens again. And this is a process I use over and over again to build reliable systems. So hopefully this talks you through the process of building reliable systems. So let's come to how to build the internet for the next billion users, or as I sometimes call, you moved from Apple to Reliance, which is a question I get a lot. So a story I'd like to share. I was very happy at Apple building robots, going to China a lot, seeing massive scale. And then someone from Reliance Jio in India reached out to me and said, Mayank, we want you to leave your job at Apple, give up your green card, come back to India and join Reliance. And I think you would agree that that's not a very common thing for people to do. But I did that. And the reason was Jio at that time was planning something that could have had a massive impact on India. They were literally planning to give high-speed internet to 1 billion Indians, which was a massive goal, right? It was like no other company in the world had ambitions at this scale, not even Apple for that matter, in my opinion. So I was thinking, hey, any team that has such massive ambitions would be a fun team to work with. So I decided to move back to India after 10 years outside. And to my surprise, even in my wildest dreams, I couldn't have imagined what Jio did for India and the amount of impact it had on India. So when I talk about building for 1 billion, a lot of this experience is what we did at Jio. So this chart shows you the number of Jio subscribers per quarter, how it grew from 0 paying subscribers to 400 million in less than 4 years. And this was probably the fastest growing startup in the world has ever seen, by the way. At least I haven't seen such a fast growing company ever. And let me walk you through the details of this. I'm just timing myself, we should be good. So Jio grew in 3 phases. For the first phase, I call the smartphone phase. The second phase, I call the feature phone phase. And the current one is the Jio platforms phase that Jio is going through. And let's talk the challenges that we faced and how we solved it in order to make this possible. So when Jio was launching, Jio is a default 4G voice over LTE network. That means it is only 4G voice over LTE and 5G and beyond, but it does not have any 2G or 3G network to fall back to. The challenge at that time was there were no phones in the market that had the voice over LTE chipset embedded in them. So no phones in the market would actually support Geo when we launched. So what we did was we launched a brand called Life, LYF, Life smartphones, which were really great value smartphones. At that time in 2017, 4 GB RAM, camera, 4-inch screen, pretty decent, pretty great value phones. And what that did was it forced all other manufacturers of phones, OEMs, the Samsungs of the world, to compete with us in that price range. So when we launched and we had VoLTE chipset embedded in our Life phones, all the other manufacturers within a few months also launched VoLTE phones, VoLTE smartphones. And within a few months, all the new phones being sold had VoLTE chipset embedded in them. So the strategy we used at that time was, hey, build a great value phone, not with the intention of making money out of this endeavor, but it was a necessary thing in order for Geo to be adopted. And every other manufacturer adopted the same VoLTE chipset. And I remember that in the first year, 130 million new smartphones were sold with the VoLTE chipset, and Geo grew to like 115 million. So if we had not done this much this fast, we would not have grown this fast. There was another challenge at that time. The process to register for a SIM card was very long. It took 48 hours roughly to register for a SIM card. You had to go to a local shop. You had to fill a form. That form used to go to a regional center. They found mistakes in that form, and they sent it back to you. So you had to correct the form again, and the entire process was 48 hours. What we did was we used Aadhaar eKYC, and then when someone walked into a store, we scanned their fingerprint and we verified them online through Aadhaar eKYC, and people got a SIM connection in 15 minutes. And that was a massive change at that time. I remember there were lines kilometers long outside Reliance stores, and people were going in 15 minutes. They were coming out with a new Geo phone and a Geo because none of our subscribers had a VoLTE phone, so most of them were upgrading to a new phone and a working Geo SIM in 15 minutes. We also built a lot of technology in order to ease this transition. So we built technology to transfer your data from the old phone to the new phone, and very quickly, in 10 minutes, all your photos, videos, music, everything was transferred to the new Geo smartphone. So this is how technology also enabled Geo to grow this fast. And we had one of the lowest data rates in the world. Geo as a network has been designed for carrying data, and voice also travels over the data network. It's a single IP network. So typically telecom networks have two separate channels, one for voice, one for data. That's how older networks were designed. Geo doesn't. It's a state-of-the-art digital network where voice and data travel together on the same channel. And it's been designed to have the lowest cost of carrying data. The cost of transferring 1 GB of data for Geo is the lowest amongst all service providers. And that's why we could offer free voice. We could offer the lowest data rates in the world. India now has one of the lowest internet rates in the world. And I think the story was evident. We grew to 150 million, 170 million in no time whatsoever. Breakneck speed. Then we come to the feature phone phase, where it was clear that we had sort of expanded enough in the smartphone market, but there is a significant market in India for feature phone users, and this is where building for a billion comes in. If you had only targeted users which were using smartphones, you would not build for a billion. even now in India, there are 320 million feature phone users. So what we did was we built Jio's smart feature phone, and we built all the apps as well for the feature phone, and phenomenal innovation there. So we built tools like you could have a dongle, you could buy a dongle from us, connect it to your Jio phone and connect it to your CRT TV or your HDMI TV. And you could watch free TV on your big screen TV. These innovations helped us scale our next phase in the feature phone phase. So we were close to 400 million, and I think that is the time I moved on from Geo. But Geo Fiber, I think, is doing well. The Geo platforms of newcomers, Geo Mart, they're all doing well. So this is the story of Geo, how Geo grew, and the challenges it faced, and how we solved it, and tools and technology enabled growth overall. So what did I take out from, and cloud in Geo was a central strategy, by the way. Let me walk you through um, what our cloud strategy was, or how it turned out. Maybe we didn't have a strategy at that time, but this is how it turned out for Geo. We started on AWS um, between 2014 and 2017. And even though we were one of the largest customers of AWS at that time, our scale was still minuscule compared to where we went to. So we were at hundreds of servers in AWS in the Mumbai data center. We quickly outgrew AWS because the scale at which we wanted to operate, even AWS didn't have that much capacity for us. Plus, it only had a single region, and for disaster recovery, that is not viable. So we moved to our own OpenStack-based private cloud. So I helped build Geo's OpenStack private cloud, and we scaled our OpenStack private cloud to thousands of servers. I think if I remember, there were about 5,000 servers running in our private cloud. 2 regions, 4 data centers, multiple availability zones, the work, like 5,000 bare metals. And orchestrating those bare metals via OpenStack, via tools and technology was something very interesting to do. And it needed great systems engineering and to build reliable systems in cloud where all our applications were hosted. And then we had the Microsoft partnership. So with Azure, we added geo regions in Azure as well. So we've moved to Azure. Many of our applications moved to Azure, but hosted in our own data centers on geo hardware. And then came the Google investment in geo, and some applications moved to Google Cloud. So maybe you couldn't call it a strategy per se, but the reality of Geo's cloud was that it is multi-cloud. And that's what I'm seeing more and more organizations be. So essentially, most organizations are trending towards multi-cloud, not just a single cloud provider. Organizations are choosing to pick up maybe ML tools from Google Cloud, other services from EC2 from AWS. So they are mixing and matching different cloud providers. That is the reality in which we operate in. Now, if I were to give me advice or give the CTO of any company advice on how to form their cloud strategy with this assumption that you will be multi-cloud, what kind of advice would I give you? The only basic advice that I would have for the CTO is that try and use standard cloud APIs that work across clouds. So what you need in order to build your tooling, so that you don't have to re-engineer your tooling for every cloud, which is redundant and it takes a lot of time and effort, is that use any APIs that are standard across clouds. And thankfully now, there is only a single choice for that API, and that is Kubernetes, right? So I'm like preaching to the choir here. Almost everyone must have heard of Kubernetes, but if you haven't, but Kubernetes is a container orchestration system. Thankfully now, every large cloud provider offers managed Kubernetes as a service. And Kubernetes is something you can depend on as APIs that are standard across clouds. So if you ever think of building your tooling, your cloud strategy, I think Kubernetes should be central to that cloud strategy. Because if you don't, you risk rebuilding all your tool chains for the different cloud when you actually try and do it on another cloud. So highly suggest looking into Kubernetes. I have a CKA certification and a CKAD certification. So they're quite useful in understanding Kubernetes. The challenge with Kubernetes is it is quite complex, unfortunately. And you need a dedicated team who understands Kubernetes and who understands how to operate Kubernetes, applications on Kubernetes in production. And that is where the real challenge lies. But tremendous advantages over virtual machines on containers and Kubernetes. Very efficient, multiple application environments on a single cluster. Utilization will go up clearly if you use Kubernetes. Consistency compared to VMs. No one can log into your container and change things because containers are immutable. So, and it forces developers to adopt 12-factor principles if you use containers in Kubernetes. Auto scaling comes native in Kubernetes. Service discovery, load balancing is there. You can do canary deployments and you can monitor resources, which for me, when I built Geo's private cloud, was very hard to do. Open source is great, but you have to mix and match tools in order to get all these features. So it takes a while. So again, if you have the choice, it's like a no-brainer to go with Kubernetes for your cloud strategy. Let's come to the next phase where Geo had grown to 400 million and I was looking for my next challenge. And that challenge turned out to be building India's largest auto tech platform at Car Dekho. But even before that, let me talk you through what is happening in India and why I'm very bullish on the next decade for India. So there have been systemic changes in India that have, I call it jet fuel, have added jet fuel to our internet economy. And these systemic changes, you can, some people call them the JAM stack, JAM stack, JAM stack. Some people refer to it as the India stack. But these are some systems that have been put in place that have radically shortened the internet pickup in India. And let me walk you through them. So one thing that the Indian government did, J stands for Jandan accounts, A stands for Aadhaar, and M stands for mobile and mobile payments. So one thing that the Indian government did was they made bank accounts free for Indians. So with Jandan accounts. And people don't need to pay a fee to maintain a bank account. What that and other fintech companies have done is that now 80% of adults in India have a bank account. And then India government demonetized the Indian currency, which forced people to put their cash in bank accounts, also removing, at least significantly reducing the black economy in India. So you have people who have money in their bank accounts. Then came Aadhaar, and India is one of the few countries in the world that has a digitally verifiable identity system that you can use to verify people are online through biometrics, through OTP. So very few countries in the world have it. In my time in the US, my identity was a piece of paper called the Social Security number. And if anyone found my Social Security number, they could impersonate me anywhere for that matter, which was very, very surprising for me. When I came to India and I found Aadhaar, I'm like, man, we live in the space age here in India. I don't know what the other world is doing. So, and because of Aadhaar and Aadhaar eKYC, Geo could scale so rapidly. So we are one of few countries in the world where you can verify people online and reliably, and people don't actually pay really to verify themselves online. And for large transaction like buying a car online at cardekho.com or getting finance online, this system is a godsend. And again, for Jio also, this was a godsend. eKYC launched coincidentally right at the time Jio was launching. And then there is something called UPI, which also no other country in the world has. UPI stands for Unified Payments Interface, where the Indian government said that the Indian people don't need to pay for transferring money online. I can pay 1 rupee to you and I don't need to pay any fee. No other country in the world has this kind of system. And and UPI is like a rocket ship in itself. The number of transactions on UPI is a doubling month over month, right? It's exponential growth. So phenomenal story there. So here's what has happened. You have people with money in their bank accounts that are accessible to the internet economy. You can verify them online and they can pay online, and they're already paying online. So you have a billion people coming online who can interact with internet companies, and no other market in the world is coming online at this scale. And that's why the next decade is India's decade. uh, Build for a billion users who can pay online, who can verify themselves online, and who have access to wide money in their bank accounts. Phenomenal systemic change. So very bullish on India. And again, my company Cardekho is also sitting right in the middle of these systemic changes. So what I'm doing at Cardekho is building a lean. I'll tell you why lean. Lean auto tech platform at Cardekho. And what we want to do is we want to be the single place for Indian car buyers to do anything related to cars, whether it is researching cars online, whether it is booking a test drive, whether it is discovering prices of cars, discovering offers on cars, whether it is exchanging their current car for a new car, booking servicing on their car, and going into used car market. New car buyers will sell their car, so they become a used car seller, making it easy to sell their car online, making it easy to discover cars online, used cars online, transparent pricing, right? No haggling, guaranteed cars. So you guarantee a car for 6 months to a year, which is unheard of in the used car market in India. You finance the car purchase, convert a 5 lakh or a 4 lakh purchase transaction into a 10,000 a month transaction, which is much easier for people to pay. So you finance and give insurance on the car. You give documentation services, RC transfer, after sale service on the car, accessories. So the reason I call this platform lean is because the DNA of of Cardekho is very lean. Whenever we do something, we have to be very efficient, no waste of any kind, no excesses of any kind. So that's the DNA of the company. So we have to build all this, but we have to be very efficient at building it, and we have to be very lean at building these things. And that is something unique that I am, picking up here. So how am I doing it? I think we have like 5 minutes or so left. So I should be done soon. But I'll tell you what we did in Cardekho and what my experience was there. So again, coming from Kubernetes and Geo, I said maybe Kubernetes would work here. We were largely on virtual machines when I joined, and massive challenges there, right? Manually configured virtual machines. No one knew how the virtual machine was configured. It went down and it took us hours, maybe a day, full day, to figure out how to bring the service back up. So we said, okay, let's do Kubernetes, right? What works in one company should work here as well. So we started there with a couple of our applications, but the key thing that we found was we simply did not have the expertise to run applications on Kubernetes in production, because Kubernetes needs a dedicated team, and there needs to be a focus on Kubernetes and an organization running Kubernetes and applications on Kubernetes, upskilling teams. It's like a center of excellence, by the way. The infra and the DevOps team is that center of excellence. But we unfortunately didn't have a significant DevOps culture, you could say. So that we tried, but we quickly figured out that's not very sustainable or scalable for us. What ended working well for us is the transition to serverless. And I'll talk you why that happened. So what we did was we skipped Kubernetes. We managed to build containers, and then we gave it to our cloud provider to run it any way they want to run it and at scale. And that actually helped, first of all, run systems reliably, and it also helped us save significant compute costs and bring reliability into our overall system. And one thing that happened recently, or I think over the last year and a half, that enabled this was serverless platforms, especially we're on AWS, by the way. AWS Lambda started supporting containers on Lambda, which is great, because then you can use a standard API, which is containers. Containers would work on every cloud provider. If you build your application just for Lambda, you would get lock-in. You would have lock-in, and then you'd sort of tie it down to your cloud provider, which we don't want. But the trade-off that we took is containers can be run anywhere in any cloud, and serverless platform on AWS started supporting containers. You just give it a container image and it runs it for you, which happened very recently. And that enabled us to transition to serverless. And we actually found that this platform is much more efficient than VMs. And it was even actually better for us on Kubernetes than Kubernetes. And let me talk you through why. Our workloads at Cardecco have this kind of usage pattern. It's a daily spike workload pattern. That means you will have peaks, but then it will die down in the night. And not every system is like this. Our websites, for example, have constant load almost all hours of the day. But especially our internal systems have, this is the typical workload pattern. And for any other company, 60% utilization, if it's hitting, this would be, hey, this is great. Don't worry about it. But for us, because we have to be very lean, we needed something better. Serverless actually gives you almost 100% utilization of your infrastructure. And you pay based on number of API calls to your serverless endpoint, which is unique, very relevant. And then the thing that you have to engineer is you have to make sure that your containers initialize very, very quickly. And there's, of course, provision concurrency that you can use to keep some containers running. But that is where the challenge lies. But here's the key message. Serverless for us turned out to be very, very efficient in terms of cost. It is very reliable. There's no virtual machine that someone can log into and change configuration and all that. That helps. But it is also very efficient and cost effective. And the place where cost comes from. So if you compare two platforms, typical couple of virtual machines in high availability, auto scaling to maybe 4 machines during peak, you would end up paying about $100 a month for that kind of environment. And in serverless, you could argue, yeah, it would be a bit cheaper, but maybe not that much on one environment. But what happens when you go to lower environments? So if you want to do proper CI/CD, you need a staging environment before production or a pre-prod environment before production, which mirrors production, which for us has almost no load, and it is used only once a week right now to do the regression testing and release, right? Or sometimes to do load testing. So you have to pay this every day for this environment. Then you come to your testing or QA environment, you have to pay for that because you need a separate QA environment. And then you have to pay for your separate dev environment. And then you have to pay for, of course, your infra support to maintain all these environments, right? This you don't need to do if you adopt serverless. If your staging environment is not being used, you won't have to pay for it. If your test environment is not being used, you won't have to pay for it. So that is where the real cost savings come from. And this is what the key message I want you guys to use to take away from. If you are in a lean organization like ours, you don't have a significant infra team, DevOps team, and you want the organization to still adopt best practices for infra and cloud. Serverless, I think, is where you should start thinking, and that has turned out really well for us. So many of our services, quite a few are now operating in production on serverless, doing really well. And that has helped us reduce costs significantly. So just to summarize, the main things that I would talk about and the lessons learned. So 4 key principles I want you to walk away with is start with process. You can use all the tools and technologies you want, but unless you have a process to build reliable software systems, you will still have issues, even using the state-of-the-art tools. So it needs to be a process which looks at the root causes and fixes the root causes so that they never happen again. Of course, containerization, if you're not doing, you're working on 5-year-old technology, adopt containers as quickly as possible, and it will help you, also help you adopt infra as code. And most organizations that I'm seeing now are multi-cloud. So use standard cloud APIs that are available on every cloud provider, and wherever possible, it will help you avoid lock-in. And thankfully now Kubernetes has become the standard, but it has its complexities. So you need to staff a dedicated team to operate applications on Kubernetes in production. And my advice to the CTO of the org would be, hey, go serverless straight away. Serverless is now ready. Use containers as the base and run containers on serverless. So you would not need to focus on Kubernetes. You could skip that and go straight to serverless. So those are the key messages I want you guys to leave with. And I had a great time speaking to you and open for questions.
Do we have any questions for Mayank?
Yeah. So one question I got was Lambda setup for Java is complex. True. There has been some recent development on AWS Lambda where you can avoid the cold starts. And you also have provision concurrency in Lambda that you should check. So that has helped us. By the way, we are largely Node and React stack, and then some PHP containers. So you could do fairly easily those two. But yeah, Java is a bit complex, but AWS has some solutions on Java as well. Another talk. Yeah, this thought of going serverless is now, I think, quite prevalent, especially on the Twitter sphere. So I'm hearing this quite a lot from thought leaders. So food for thought, something to consider.
We have another question for you. What exactly was better in serverless than in Kubernetes? Cost, scalability, or other?
Well, you don't need to staff a dedicated team that understands Kubernetes. So for me, that was a challenge in my current organization at Cardeco. So, and then once you build the tooling, so like first, there's a CLI called SAM in AWS. If you use that, essentially it deploys a container for you very easily on serverless. So it is, first of all, no need for training your team on Kubernetes, which is a special skill and needs dedicated focus and very, very efficient. So your internal systems that don't get used constantly are a great fit for serverless. It's a no-brainer to move them to serverless because the cost saving that you'll realize is massive. The cost analysis that I showed, again, depends. Depends on workload to workload, but you can have 80-90% compute savings easily in one application for all your environments combined. So definitely worth looking at and analyzing before doing that. Serverless, again, is not like the right answer for every application. So there are some pitfalls there. Might be worth another talk, but yeah, just analyze before going to serverless.
Okay. I think that's another question. Since Lambdas are short-lived, how are you monitoring the app workloads, metrics, traces?
So the good thing is Lambda is integrated with CloudWatch very well. So, and then all your application performance monitoring tools like New Relic, they support Lambda. So very easy to monitor your response times, your errors. It's almost native for AWS at least. So if you look at your Lambda function, you'll have your response times, you'll have your error rates, you'll have logs integrated. It'll force you to output to std out, which is a best practice, right? 12-factor principle. So it'll help you avoid principles like maintaining files for logs and all that. So very good observability for Lambda in AWS. Plus all the APM tools integrate with Lambda very well now.
Okay. Any more questions for Mayank? I think there are no more questions. Thanks a lot, Mayank, for an insightful talk. If there
My
are
pleasure.
If there are any questions, please type it in Q&A, and we'll make sure that Mayank answers those questions.